Hello everyone, welcome to today's video. We're going to be working with the same geometry that we had for the previous harmonic load example, but this time rather than applying a harmonic load, we're going to actually apply a custom time varying load to this model. So I have all the same geometry, and under the loads window I've got this time varying load that I'm actually going to get rid of here. I don't need it for this example. What I'm going to have instead is I'm going to create a new time history load using the time history tool. So I'm going to right click on the time history tool, and rather than use the test curve function that I had already previously defined, which had a harmonic function, I'm going to click on the chart button, and this allows me to either create a new DTH file, which is a database of time history curves, or I can append the existing one with data that I might be interested in. That's the approach I'll take this time. I'm going to use the user-defined function rather than a standard function. I'll click on the user-defined function, and I'm going to give the curve a new name. I'll just call this simple blast. And what I've done here is I've basically got these two columns, one for time in seconds and one force in kilonewtons. And I'm going to just import the data from Excel, just copy and paste the data. And I've got this Excel sheet handy here that just describes a very simplified blast loading function, essentially. We can see the curve here has just been, again, stretched out during the blast portion. You can see the increments that we have. So it's fairly finely close time steps, I guess you could say, in this loading function. But I'm just going to copy and paste this and go back into here and copy and paste the data that I need into this plot. So you can see here that I have a total duration of 5 seconds that I'm applying this load for. And for most of the time, it has a magnitude of 0 kilonewtons. It does spike to 100 kilonewtons and then to 150 kilonewtons, and then goes back down to 25, all within a very short period of time before going back to 0. And I'm just going to say, let's add this curve. So I'm going to add this curve to the same DTH file that contains my harmonic test curve. I could have also just updated the curve if I wanted to overwrite the harmonic curve, but I don't want to do that. I want to have them both in the same file. So I'll click Add Curve. And it may be hard to see because this happens in really just a split second, but we have this spike in our plot, and then it goes down. I'm just going to click OK, and it's going to ask me to save the file. So I'm going to save this file again. Let me just move it over to the other desktop. And I'm saving it. I'm overwriting the original one because I want to apply that I want to be able to apply different curves to different models from within the same file. It just makes it easier for me to manage. Now I've got this simple blast load and the test curve, which is my harmonic load. I'm going to click OK. And with the time history tool now, I can see that this is the function that I've got. I'm going to specify the direction I want to apply it to. I'm going to go with X translation, enter the X scale of 1, and enter the Y scale of 0, and just left click and apply it to this particular joint here. Now this joint is my top of my column. I could have applied to any joint in my model. I can have different curves at different joints if I want to, in different directions. Now I'm going to go ahead and run the analysis. And because I have such a short duration load that I'm applying, I want to be able to run an analysis that considers that. Now for a blast load, I would normally recommend nonlinear dynamic time history analysis, but we're just going through the process of applying this load, so I'm not going to worry about that right now. But in this example here, we can see our time step size, and I'm actually going to bump that down a little bit more. And I'm going to increase the number of time steps, so I have a total of 5 seconds of load duration that I'm considering. So I want to make sure that I'm able to consider that entire time. So I'm just going to apply the total number of time steps here, and I'll click OK to run. I could have also run a variable time step integration. We'll look into more of that later on in future videos. But I'm going to click OK to run the analysis. Now that the analysis is completed here, we can see that it ran through all time steps, and it's just letting us know again about the initial conditions being equal to 0. It's an FYI, but again, as we mentioned in the previous video, this isn't necessarily an issue. It's just something the solver is letting us know. We didn't define any initial conditions, any initial velocity or displacement, so this really shouldn't come as a surprise and shouldn't prevent us from looking at our results. Now we can look at this in SView and look at the response. Let me just drag this over and perhaps look at a front-facing view here. So again, we're applying the load to this joint right up here, and I've just adjusted the duration and kind of the speed and magnification factor that we're going through this type of loading. So there's no loading, and all of a sudden we have a lot of loading, and then we let it go. So this is what it will look like. As you can see, it really just kind of stretches it out, and then there's a bit of oscillation at the bottom just due to some existing damping that I haven't gotten into. And then it disappears, so it's been damped out. We could also use numerical results to plot this and to maybe dive into it a little bit deeper, and I've plotted this in advance just to show you here the displacement versus time, just looking at a small duration of that time period that we had. So we can see here that the displacement sharply goes down, then it kind of overcorrects and oscillates just a little bit, so I would say it's very highly damped for this system, and then it just has zero deformation or very negligible deformation after that point. And this is something that we can observe from a time history analysis. Obviously we have control over the damping, over the time steps that are used and so on, so we can really study this type of behavior in more detail.